Hi students, in this video we are going to discuss about harmonic analysis of cantilever beam. You have two types of frequency we estimate from this analysis. One we called as a natural frequency, another is we called as a forced frequency. Normally in natural frequency can be estimated by using model analysis. Harmonic analysis will be used for when we apply the used to find the forced frequency. When you are apply the load to the particular system, it will generate the frequency. That load, based on the load, then the frequency will be calculated. That is we call as a forced frequency. You are going to estimate the forced frequency using harmonic analysis. In this video, we are going to see for cantilever beam using ANSYS APDL software. This is a harmonic analysis. Again, the dimension, I can select the dimension of the beam. This is the dimension of the beam. We have a 1 meter length, then 0.01 meter, 0.01 meter. We have a Young's modulus, Poisson ratio, and a weight density, right? Okay, this is the dimension of the beam. We are applying the load is 100 Newton downwards in y direction. Frequency is 1 to 100 Hz, right? We are going to solve this problem by using ANSYS APDL in harmonic analysis. You go for preference, structural, you OK, preprocessor, element type, add element type, you can add beam 3D final strain 2 node 188, click OK, close. After adding the element type, I wanted to add the mechanical properties or material properties, right? Material properties, material model, structural, linear, elastic, isotropic, 200 e power 9, right? 0.3, right? 0.3, density is 7850. I'm adding it to OK. Add it, right? Next we go for metal properties has been arrived. Next we go for section. You want to give the cross section of the beam. Then you go for section, beam, common section. In common section you can give 0.1, because the 0.01 is the meter, right? 0.01. You can give 0.01, 0.01. This is the cross section, right? Okay. After giving the section, you want to model the beam, right? Modeling, create key points, inactive CS. You can start with 1, usually 0, right? Initially you can start with 1, 0. Next you go for second point, key point, second. What is the distance, x distance you have to is give 1 meter. You will give 1 meter. You can give 1 meter. These two key points has been created. After creating these two key points, you have to join these key points by using lines, straight line. Select the first key point, second key point, then give OK. Automatically the line has been created. After creating the line, you want to mesh this line, right? Why we are meshing it? You have to convert this 3D model into finite element model by doing discretization, right? Meshing, mesh tool, lines, set, select this line. After selecting, you can give the select the element 50, number of decision is 50, give OK. You can discretize it. Then you go for meshing tool, here mesh, select this button, give OK. Automatically it will be meshed. After meshing, you have to give the load, right? Go to preprocessor, load. You have to select the first, you have to select the analysis, new analysis. Now I am going to do harmonic analysis, right? Harmonic analysis. Meanwhile, we can close this button, close. Harmonic analysis, give OK. Define load, apply, structural displacement, right? I wanted to give the displacement. Why is because it is cantilever beam, one end is going to be fixed in all degrees of freedom, right? On key points, select this key point, give OK, all degrees of freedom, OK. This is going to be all degrees of freedom. I am going to fix it, right? Next, I am going to apply the force in downward y direction, right? Force on key points, select this key point other end. I am going to give the direction y direction, y axis, direction downward, so that I am giving a minus 100. This is the load I am giving, minus 100 downwards, right? Then okay. After giving this load, I wanted to give the load step option, right? Go for load step option. In load step option, you go for time and frequency. In time and frequency, you go for frequency and substeps, right? Frequency and substeps. What is the range? 0 to 100. 0 to how many steps has to convert? In 0 to 100, how many steps has to be controlled? I am giving 10. I am giving a step because I am doing a step analysis. Each step it will be calculated. So I am given as step. You okay. You okay. After giving this step analysis, then you go for again. You can go for solution, solve currentless. Solution, solve currentless. You okay. Once the solution done, see that solution has been done. We have solved the apply the load, we have done the solution, solve currentless, right? The solution is done, right? We have to extract the result. We have to extract the result, right? You go for time history post processor. Time history post processor. Automatically this graph will come, right? Automatically time is post processor. This box will be window will be coming, right? You can select this add data. Add data. This looks like a green. You can select the add data. DOF. DOF. I wanted to get the displacement in y direction. Y direction only the frequency will be acting, right? Because we are applying the load in y direction, right? Y. Select the y. Give OK. Give OK. Select this point, right? You have to select this point because we are applying the y direction, so that we have to apply this point and give OK. Automatically this data will come minus 0.0. This will be minimum and maximum, right? Then you can take this third option we call as a graph data. You can click this graph data, then close it. Automatically the graph has been plotted, right? Where which is going to be, this is the maximum amplitude, right? Under 50 Hz there will be a maximum displacement. Initially it will be displayed by the value of a higher value. Again it will be down, again it will be up. This is the maximum peak value, peak displacement. We call as amplitude, maximum amplitude of the beam, right? For corresponding 100 Newton load, right? I wanted to check it to a clear, detailed manner in logarithmic scale. I wanted to change this data into logarithmic scale. Plot, right? Style, graph, right? You can modify the axis, right? You can plot control, style, graph, modify the axis, select the modify axis. Single, double, you can select it. Here you can select a logarithmic. I wanted to view in a proper entire channel fast frequency. I wanted to find each substeps, so that I go for logarithmic. Give OK. Give OK. Then you go for plot, replot. Plot, replot. Plot, replot. Click, it is plainly plotted, right? You can see that what are the maximum amplitude alone, you can display it. Here the maximum amplitude, this is also maximum 1.e power minus 0.1. This is the maximum amplitude of the beam which is corresponding to 100 Newton load with the frequency of 0 to 100 Hz, right? We are finding the forced frequency and the maximum amplitude of the system by conducting the harmonic analysis, right? Thank you for watching my video. Thank you.